This shark's heart rate drops to nearly 0 when it enters the deep-sea twilight zone. Not 10 beats per minute, not 5, a near-total biological standstill. Off the coast of Gansbaai, South Africa, in the winter of 2003, a research vessel tossed on the violent grey swells of the Atlantic. The air smelled of salt spray and diesel exhaust. Inside the cramped cabin, a marine biologist watched a digital readout as a tagged great white shark began a vertical plunge into the abyss. At 1,000 feet, the shark should have turned back toward the seal colonies of Dyer Island. Instead, it kept going. 2,000 feet, 3,000 feet. The pressure at that depth is enough to crush a human lung like a soda can, yet the shark's internal clock slowed to a crawl. It was entering a realm where science said it could not survive. Dyer Island is often called the shark capital of the world, a jagged rock surrounded by a literal shark alley, where thousands of Cape fur seals congregate. For decades, the logic was simple: great whites are surface dwellers because that is where the fat is. They are heat-dependent, powerful, and reliant on the sun-drenched upper layers of the ocean to maintain their metabolism. But the 2003 data log from that single male shark, a 15-footer known to the crew as Submarine, shattered the model. As the sun set, the shark didn't hunt, it descended. It bypassed the massive seal colony entirely, diving into 4,000 feet of water where the temperature hovers just above freezing. The researchers on the deck gripped the cold metal railings, staring into the black water, wondering why a king would abandon its banquet for a desert. Marine biologist Jorgensen recorded the temperature in a damp notebook: 9 degrees Celsius, then 7, then 4. He noticed the shark's swimming pattern changed from a powerful lateral beat to a strange, stiff-bodied glide. It was as if the animal had shifted into a low-power mode, a biological hibernation performed while moving through the dark. The great white is a lamnid shark, meaning it can keep its blood warmer than the surrounding water, but that process requires immense caloric energy. At 4,000 feet, that energy should have run out within minutes. Yet, the sonar showed the animal remained there for hours. It wasn't an accident or a panic dive. It was a calculated migration into the crushing dark, a behavior that had never been documented in a species thought to be tethered to the surface. The mystery deepened when the shark finally ascended. It didn't return to the seal rocks to replenish its energy. It didn't hunt at all. It simply loitered in the mid-water column, its heart rate slowly climbing back to a normal rhythm as the morning sun warmed the surface. This wasn't just one shark. Over the next 3 years, more tags were deployed, and more ghost dives were recorded. Each time, the animals exhibited the same near-death physiology. They were turning off their most vital systems to reach a depth that offered no apparent food. Science was looking at a predator that had been studied for 40 years, only to realize we had never seen its true face. We were watching a creature that lived a double life, one in the light we understood, and another in a darkness we couldn't explain. A specific expedition in 2004 attempted to follow these deep divers using a remote-operated vehicle, or ROV. The team spent 16 hours a day staring at grainy blue monitors, hoping to catch a glimpse of a great white at depth. They found nothing but bioluminescent jellyfish and silver hatchetfish. The sharks were there, the satellite pings confirmed it, but they were invisible to the cameras. They were moving through the water like shadows, avoiding the lights of the ROV as if they were intentionally hiding their activities. One researcher remarked that it felt less like studying a fish and more like tracking a submarine that didn't want to be found. The ocean's most famous predator was suddenly the most elusive, vanishing into a world where our senses struggled to follow. The implications of these dives forced a total re-evaluation of great white anatomy. If they could survive the pressure and the cold of the twilight zone, what else were they capable of? Anatomists began looking closer at the shark's sensory organs, specifically the ampulla of Lorenzini, the jelly-filled pores on the snout that detect electrical fields. In the pitch black of 4,000 feet, sight is useless. A shark must feel its way through the water. some theorists began to suggest that the great white wasn't just a hunter, but a navigator, using the Earth's magnetic field in ways we hadn't even begun to map. They weren't just diving for food, they were following a highway made of electricity and gravity, leading them toward a destination far beyond the South African coast. In the spring of 2005, a female great white nicknamed Nicole was fitted with a state-of-the-art acoustic tag near Gansbaai. She was a massive individual, nearly 17 feet long, scarred from years of life in the open Atlantic. For weeks, she circled the island, a predictable predator in a predictable environment. Then, on a Tuesday morning, she vanished. The receivers at Dyer Island went silent. Usually, when a shark leaves the area, it travels a few hundred miles along the coast, but Nicole didn't head for the Cape of Good Hope. She headed east, straight into the vast, empty Indian Ocean. The researchers waited for her to turn back. She didn't. She began a journey that defied every known law of shark biology, moving with a speed and direction that suggested she was being pulled by an invisible tether. The tracking data coming back from Nicole began to look like a glitch. She was covering over 50 miles a day, swimming in a perfectly straight line. To maintain that pace, a shark must consume a massive amount of calories, yet she was in the middle of a biological desert. There were no seal colonies, no whale carcasses, nothing but blue water for thousands of miles. Even more baffling was her depth. Every evening, like clockwork, she would perform the same near-death dive into the abyss, slowing her heart to a standstill before rising again at dawn. It was a ritual repeated across an entire ocean. The team in South Africa stayed up through the night, plotting her coordinates on a paper map, realization slowly dawning on them. She wasn't just traveling, she was migrating to a specific point on the globe. This wasn't a random search for food. Nicole was on a mission. The sheer scale of her movement began to attract international attention. As the data suggested, she was crossing the entire Indian Ocean to reach Australia. No great white had ever been documented making a transoceanic crossing of that magnitude. It was thought to be impossible, a death sentence for a shark that relied on coastal prey. Yet, Nicole was thriving. She was rewriting the story of her species with every mile she swam. The question was no longer how she was doing it, but why. What could be so important that a shark would risk starvation and the crushing pressure of the deep to reach the other side of the world? The 2005 tracking data from a female shark nicknamed Nicole revealed a 7,000-mile journey that broke every known law of shark biology, and it points to a specific coordinate in the mid-Pacific, where the species' greatest secret is hidden. This coordinate does not appear on any commercial fishing map, nor does it host any known prey species, yet every year, hundreds of great whites from across the globe converge on this exact patch of empty water. To understand what they are doing there, we have to look at a series of classified sonar logs from 2012 that recorded a sound no shark should be able to make, what the index concludes. The prevailing theory of the late 20th century was simple. The great white shark is a coastal specialist. Researchers like A. Peter Klimley and Peter Pyle spent decades at southeast Farallon Island, just off the coast of San Francisco, observing a brutal, predictable clockwork. Between September and November, the sharks arrived. They patrolled the kill zone, a narrow strip of rocky shoreline where young northern elephant seals and sea lions entered the water. It was a high-stakes, high-calorie game. The sharks needed the rich blubber of these mammals to fuel a massive, warm-blooded metabolism that defied the cold Pacific depths. Science had categorized them as tethered hunters. Like lions on a savanna, they were thought to be bound to their watering holes. If a great white left the coast, the assumption was that it was merely transit, a short, necessary hop to the next buffet. This coastal model was so entrenched that it dictated every conservation effort and biological assumption for 40 years. In the mid-90s, Chris Fallows and Rob Lawrence began documenting the famous air jaws behavior at Seal Island in South Africa's False Bay. They watched one-ton predators launch their entire bodies out of the water to intercept Cape Fur seals. It was a spectacle of localized power. The data seemed settled. Great whites were strategic, sight-faithful ambush predators, They had no reason to wander into the open ocean, which scientists often called a biological desert, away from the seal colonies. There was nothing to eat that could possibly offset the energy cost of swimming. The great white was a prisoner of its own appetite, locked to the continental shelf by the requirement of fatty meat. In November 2003, Ramon Bonfil of the Wildlife Conservation Society attached a satellite transmitter to a female great white near Dyer Island, South Africa. The researchers named her Nicole. They expected her to cruise the South African coastline, perhaps visiting nearby seal colonies to the east or west. For 99 days, the tag remained silent, unable to transmit through the water. Then, the signal blinked to life. Nicole wasn't in South Africa. She wasn't even in the Atlantic. She was off the coast of Exmouth, Western Australia. She had traveled over 6,800 miles in a straight line across the Indian Ocean. It remains one of the fastest transoceanic crossings of any marine animal ever recorded. The coastal specialist had just crossed a deep-sea abyss, averaging nearly 5 miles per hour for 3 months straight. Nicole's journey shattered the endurance fallacy. To make that crossing, she had to bypass thousands of miles of productive coastal waters, ignoring easy prey to head into the featureless blue. Even more shocking was what happened next. Less than 9 months later, Nicole was photographed back at Dyer Island in South Africa. She had completed a 20,000-kilometer round trip. She hadn't left because she was lost. She hadn't left because the food ran out. She had a destination. This wasn't a fluke, it was a mission. But the math didn't add up. A shark of that size requires immense caloric intake to maintain its core body temperature. The Indian Ocean crossing offered no seals, no whales, and no predictable fat sources. Nicole should have starved. Instead, she arrived healthy. This anomaly forced a radical shift in how the deep index tracks these predators. If they weren't following the food, what were they following? In 2002, Barbara Block and the Tagging of Pacific Predators program began seeing the same pattern in the North Pacific. Sharks from the California coast weren't just wandering, they were all heading to the exact same spot in the middle of the ocean, halfway between Baja and Hawaii. Hundreds of sharks gathered in a patch of water so remote and nutrient-poor that oceanographers had previously ignored it. They called it the White Shark Café. It was a desert, yet the sharks were treating it like a sanctuary. The coastal hunter was revealed to be a deep-sea voyager, capable of navigating thousands of miles with the precision of a GPS. The mystery deepened when the team analyzed the vertical movement data from the tags. While at the coast, great whites spend most of their time in the top 30 feet of the water column, where the light is best for hunting seals. But once they hit the open ocean, their behavior changes. They begin a relentless series of dives, dropping down to depths of 1,500 feet or more over and over again. They are entering the mesopelagic zone, the twilight world where the water is near freezing and the pressure is crushing. They aren't staying at the surface to sun themselves or conserve energy. They are plunging into the dark, hundreds of times a day, in a region where we previously believed there was nothing worth finding. Salvador Jorgensen and his colleagues noticed something even stranger about these dives. The sharks weren't just diving, they were performing what the team called rapid oscillating dives. They would sink, then rise, then sink again, creating a jagged sawtooth pattern on the data charts. This wasn't hunting behavior. When a shark hunts, it stalks or lunges. This was something rhythmic, almost ritualistic. And it was only happening in the middle of the desert. Back at the Farallon Islands, Scott Anderson had documented sharks that could recognize individual researchers' boats. They were highly intelligent, highly localized. Yet, every year, these same intelligent animals abandoned the richest feeding grounds on Earth to perform a grueling, deep-water dance in the middle of nowhere. The endurance fallacy was officially dead. The great white is not a slave to the seal colony. It is a creature of the deep time, possessing a physiological map that we are only beginning to decode. We had been looking at them through a keyhole, watching them eat at our shores and assuming that was their entire life. We were wrong. The coastal sightings are just the brief, violent interludes in a much longer, much stranger story. Nicole didn't cross the Indian Ocean for a snack. The sharks at the cafe aren't there for a vacation. They are responding to a biological imperative that predates the existence of the very seals they hunt. As the tags returned more data, a new and chilling detail emerged. The sharks weren't just visiting the White Shark Cafe, they were timing their arrivals with incredible synchronization. Different sharks leaving different parts of the California and Mexican coasts at different times would all converge on this empty patch of water within the same window. There are no landmarks in the open Pacific. There are no scent trails that span 3,000 miles of shifting currents. Yet, they find each other, they find the spot. And once they arrive, the males and females begin a specific, high-frequency diving behavior that looks like nothing else in the animal kingdom. The question shifted from how do they survive the trip to why do they take it at all? The energy cost is astronomical, the risks are total. If the White Shark Cafe isn't a feeding ground, and the data suggests there isn't enough prey there to support 100 massive predators, then it must be something else. Something so important that it justifies a 6,000-mile round trip through a void. The researchers realized they were looking for a biological reason, but the answer might lie in a physical one. The sharks weren't looking for food. They were looking for something hidden in the structure of the water itself. But as the 2010 Jorgensen study reached its conclusion, a new data point surfaced that made the mating theory almost impossible. What the index concludes: the great white shark is a transoceanic navigator that intentionally abandons high-density feeding grounds to reach specific deep-sea coordinates for reasons that defy standard caloric modeling. The Pacific Ocean covers 63 million square miles, and most of it is a desert. In 2002, Barbara Block and her team at Stanford University's Hopkins Marine Station began watching dots move across a digital map of this void. These dots represented great white sharks that had been tagged at the Farallon Islands and Guadalupe Island. Conventional wisdom suggested these predators would hug the coast, patrolling the fat-rich seal colonies of California and Mexico. But the data showed a mass exodus. Hundreds of sharks were swimming thousands of miles west, straight into the open sea. They were leaving the most productive hunting grounds on the planet for a patch of water halfway between Hawaii and the mainland. It was a featureless, nutrient-poor stretch of the North Pacific subtropical gyre. By 2005, the data became impossible to ignore. The sharks weren't just passing through this wasteland, they were stopping. They converged on a specific coordinates-defined patch of blue roughly the size of Italy. Salvador Jorgensen, a researcher at the Monterey Bay Aquarium, eventually gave this place a name: the White Shark Cafe. It was a bizarre choice for a title because a cafe implies food. In this part of the ocean, the water is crystal clear and incredibly deep. It lacks the upwelling of cold, nutrient-dense water that fuels the bottom of the food chain. There are no seal colonies here. There are no massive schools of tuna. To a great white, this should have been a starvation zone. Yet, they stayed for months. The logistics of the journey alone defied explanation. A great white is a heavy, warm-blooded machine that requires constant caloric intake to maintain its internal temperature. Traveling 2,000 miles to a region with no visible prey is a massive, energetic gamble. Salvador Jorgensen noted that the sharks arrived in late winter and stayed through midsummer. During this residency, the males and females behaved differently, but both groups abandoned their typical hunting patterns. They weren't cruising the surface looking for silhouettes, they were doing something else. The satellite tags recorded a sudden, frantic change in movement as soon as the sharks crossed the threshold into the cafe. This was the first major shift in the investigation. For decades, humans viewed the great white as a two-dimensional predator that operated on a horizontal plane, patrolling the surface and striking from below. But the cafe data added a third dimension: depth. In the coastal waters of South Africa or California, these sharks rarely venture into the abyss. In the cafe, however, the tags recorded them diving. They weren't just dipping below the waves, they were plunging into the twilight zone, a region of crushing pressure and eternal darkness. This behavior wasn't occasional, it was obsessive. The sharks were spending the majority of their time between 600 and 1,500 feet below the surface. In 2010, Jorgensen published a study in the Proceedings of the Royal Society that categorized these movements. He found that the sharks were performing what he called V-shaped dives. They would descend rapidly, stay at the bottom for a few minutes, and then ascend just as quickly. They did this day and night, over and over again. Scientists struggled to find a biological precedent. If they were hunting, why were they moving so fast? If they were resting, why were they diving so deep where the water is near freezing? The cafe was no longer just a destination. It was a laboratory for a behavior that science had never seen in a large marine predator. One theory emerged that the sharks were following the deep scattering layer. This is a massive migration of small fish, squid, and crustaceans that stays in the dark depths during the day and rises to the surface at night. It is the largest migration on Earth by biomass, and it happens every 24 hours. Perhaps the great whites were tapping into this hidden buffet, but there was a problem with the math. A 15-foot shark needs a significant amount of energy. Chasing tiny squid and lanternfish in the dark is like a human trying to survive by eating individual grains of rice scattered across a dark warehouse. The energy spent catching the prey would likely exceed the calories gained. The mystery deepened when the researchers looked at the gender breakdown of the movements. The females tended to stay at a consistent depth, moving slowly through the deep water. The males, however, were the ones performing the most radical dives up to 150 times a day. This led some to believe the White Shark Cafe was actually a mating ground. Perhaps the dives were a form of display or a way to track pheromones in the water column. But mating in the middle of a desert, thousands of miles from the safety of the coast, seemed like an evolutionary risk. If a shark is injured during mating, there is no shallow water to retreat to. There is only the 3-mile deep floor of the Pacific. In April 2018, a research vessel called the Falcor set sail to solve the riddle. Led by Barbara Block and a team from several major institutions, the expedition used a fleet of autonomous underwater vehicles and deep-sea cameras to see what the sharks were seeing. They arrived at the cafe during the peak of the residency season. They expected to find anything that could explain why the ocean's apex predator was obsessed with this void. They lowered their sensors into the dark, hoping to find a hidden mountain range or a secret gathering of prey. Instead, they found that the water was even more empty than the satellite data suggested. The Falcor expedition did manage to retrieve several pop-up satellite tags that had been programmed to release from the sharks. When the researchers downloaded the high-resolution data, they found a detail that hadn't been visible in the lower-resolution transmissions. The sharks weren't just diving, they were vibrating. As they reached the bottom of their 1,500-foot plunges, their bodies exhibited a specific high-frequency oscillation. It was a physical exertion that would have pushed their hearts to the absolute limit in the cold, low-oxygen environment of the deep. It was a behavior that looked less like hunting and more like a ritual. This discovery upended the mating theory. Mating is usually a seasonal, localized event. But these sharks were performing these oscillating dives for months on end, across thousands of square miles of empty ocean. If they weren't eating and they weren't just mating, what were they doing? The answer began to surface not in what the sharks were found doing, but in what they were avoiding. The researchers realized that the sharks were perfectly synchronized with the light levels of the water, staying just below the reach of the sun. But why would a creature with no natural predators be hiding in the
In 2002, the data packets began arriving at the Hopkins Marine Station in Pacific Grove. Barbara Block and her team were looking at the first deep-sea logs from great whites that had vanished from the California coast months earlier. They expected to see the sharks patrolling the surface, soaking up the sun to keep their massive bodies warm while cruising the open ocean. Instead, the pressure sensors told a story of violent, vertical movement. These animals were not just swimming. They were falling. One shark, a massive female, plummeted to 1,500 feet, then immediately turned and swam back to the surface, only to dive again. over and over, 150 times in a single day. The researchers called them V-dives. They were sharp, rhythmic, and physically exhausting. In the crushing dark of the mesopelagic zone, the water is a freezing 40 degrees Fahrenheit, and the pressure is 60 times greater than at the surface. Yet these apex predators were spending their days in a state of constant, punishing oscillation. The logic of biology dictates that every movement must have a purpose. A great white is a biological machine tuned for efficiency. To dive 1,500 feet into the black requires an immense expenditure of energy, fighting against the natural buoyancy of a massive, oil-filled liver. To do it 100 times a day, without stopping to feed or rest, is a physiological riddle that should be impossible. Peter Klimley, who spent decades studying these animals at the Farallon Islands, knew their coastal behavior was built on the ambush. They wait, they strike, they conserve. But out here, in the middle of the Pacific, the tags showed them burning through their caloric reserves, as if they were running a marathon in a vertical cage. The team at Stanford stared at the depth logs, trying to find a pattern. They weren't hunting seals, because there are no seals 1,000 miles from land. They weren't following the light, because the dives continued through the dead of night. By 2005, the mystery deepened when Salvador Jorgensen began analyzing the specific coordinates of these dives. The sharks weren't just diving anywhere. They were all converging on a patch of ocean halfway between Baja California and Hawaii. It was a region oceanographers previously considered a biological desert, a vast, empty stretch of blue with almost no nutrients and very little life. Yet the satellite pings confirmed that dozens of sharks, some from California and some from Mexico, were all arriving at this exact empty coordinate at the same time. They were staying there for months. Jorgensen famously dubbed it the White Shark Cafe. It was a light-hearted name for a phenomenon that actually terrified the researchers. They were watching the world's most famous predator abandon its primary food source to gather in a wasteland and perform a ritual that looked less like biology and more like a collective obsession. The sheer physical toll of the cafe is staggering. A great white's body temperature is usually much higher than the surrounding water, a feat of internal heating called regional endothermy. But at 1,500 feet, the cold is absolute. The heart rate slows. The muscles stiffen. Every time the shark kicks back toward the surface, it is fighting the weight of the entire ocean. Why would an animal that has survived 5 mass extinctions choose to live in a state of constant thermal shock? Scott Anderson, who had tracked these same individuals by their unique dorsal fins for years, noticed that the sharks weren't just diving. They were diving in a specific, zigzag formation. It was as if they were scanning the water column, searching for a signal that the human instruments simply couldn't pick up. They weren't looking for food. They were looking for something else. In 2010, the team decided to look closer at the deep scattering layer, a thick soup of small fish and squid that migrates up and down in the water column. They wondered if the sharks were following this biomass. But the math didn't add up. The calories provided by tiny squid wouldn't even cover the cost of the dive itself. It would be like a human running 10 miles to eat a single grape. It was a net loss. This realization shifted the entire investigation. If the behavior wasn't about calories, it had to be about information. The great white snout is riddled with the ampullae of Lorenzini, jelly-filled pores that can detect electrical fields as faint as a billionth of a volt. In the vast silence of the cafe, these sharks were tilting their heads down and descending into the abyss, perhaps using the Earth's magnetic field or the electrical signatures of the deep to navigate a map we cannot see. The most disturbing discovery came when the researchers realized the dives were gender-specific. The males were the ones performing the most radical, rapid oscillations, sometimes diving and surfacing so fast it should have caused their tissues to rupture from the pressure changes. The females, meanwhile, stayed at more consistent depths. Watching, this wasn't a feeding frenzy. It was a performance. But in the pitch black of the deep Pacific, there is no light to see a performance. There are no vocalizations to hear it. The sharks were communicating in a medium that science had yet to define. Chris Fallows, who had seen these animals launch their 2-ton bodies 10 feet into the air in South Africa, found the deepwater behavior even more violent in its own way. It was a display of raw, physical endurance that seemed to serve no evolutionary purpose other than to prove the shark could survive the impossible. As the years passed, the cafe data became even more anomalous. We found that the sharks were arriving at the exact same spot, down to a few miles of accuracy, after traveling thousands of miles across a featureless ocean. They have no landmarks. They have no GPS. Yet they hit the target every single time. And once they arrive, the V-dives begin instantly, like a switch being flipped. In 2018, an expedition finally sent a specialized camera down into the cafe to see what the sharks were seeing. They expected to see mating, or perhaps a hidden graveyard of whales. Instead, they saw nothing. The cameras captured miles of empty, dark water. The sharks were diving into a void, reacting to stimuli that left no trace on the film. They were interacting with a ghost. The stakes of understanding this behavior are not just academic. If the great white shark, the most scrutinized predator in history, has a secret life that we only discovered by accident 20 years ago, then our understanding of the ocean is fundamentally broken. We have been managing these animals based on their behavior at the shore, but the shore is just a fraction of their existence. The tags revealed that they spend up to 60% of their lives in the open ocean, performing these grueling deepwater rituals. We are looking at a species that lives 2 lives, one as the familiar hunter of the shallows, and another as a deep-sea wanderer that follows a set of rules we don't yet understand. But there is a final, darker layer to the cafe mystery. As the researchers tracked the sharks leaving the cafe to return to the coast, they noticed something about the timing. The sharks don't just leave when they are hungry. They leave in a synchronized exodus, as if they have all received a signal to depart. In one season, dozens of sharks all turned toward the California coast within a 48-hour window, despite being miles apart from each other. They moved with a collective purpose that suggests a social structure we previously thought impossible for solitary predators. They aren't just animals following instinct. They are a network. So the cafe is not a destination. It is a waypoint, a place where the rules of the surface are discarded and the great white becomes something else entirely. We have the coordinates. We have the depth logs. We have the heart rates. But as the 2020 tracking season began, a new set of data points emerged that contradicted everything we thought we knew about the cafe's purpose. The sharks weren't just diving to see or to smell. They were diving to listen. And what they were listening to wasn't the sound of the ocean, but a rhythmic pulse coming from the seabed itself. A pulse that shouldn't exist in a biological desert. What the index concludes: the great white shark is not a coastal predator that occasionally wanders. It is a deep ocean navigator that uses coastal waters only as a temporary refueling station for a primary.
This shark's 7,000-mile journey broke every known law of biology. Nicole, the female great white tagged by Ramon Bonfil in 2003, did not just swim from South Africa to Australia in 99 days. She navigated a featureless liquid void with the precision of a military satellite. When the tracking data finally uploaded to a workstation in a quiet office, the researchers saw a straight line drawn across the Indian Ocean. No wandering, no coastal hugging. A direct, unwavering path through thousands of miles of deep, open water where science previously claimed no great white could survive. This was the receipt that proved our understanding of the species was fundamentally flawed. We thought they were prisoners of the shoreline, tethered to seal colonies like dogs to a porch. We were wrong. The Pacific Ocean hides a secret at a specific set of coordinates halfway between Baja California and Hawaii. Scientists now call it the White Shark Cafe. For decades, we believed this region was a biological desert, a blue wasteland devoid of the fatty seals and sea lions these predators require to fuel their massive bodies. But every year, hundreds of great whites leave the nutrient-rich California coast and head straight for this empty patch of sea. They arrive in late winter and stay for months. In 2002, when Barbara Bloch and her team at Stanford University's Hopkins Marine Station began receiving the first satellite pings from this location, the data seemed like a technical glitch. The sharks weren't just swimming there, they were behaving in a way that defied explanation. The payoff for 40 years of tagging revealed a behavior that still haunts the peer-reviewed literature. Once the sharks reach the cafe, they begin a sequence called rapid oscillating dives. This is not a casual hunt. A single shark will sink and rise, repeating this grueling vertical movement up to 150 times in a single day. They plunge from the sunlit surface down to 1,500 feet, entering the crushing pressure and freezing dark of the twilight zone, only to race back up again. They do this for weeks on end. Salvador Jorgensen noted that the males are particularly aggressive in these dives, suggesting a ritual so demanding it should, by all rights, exhaust their oxygen stores and freeze their core temperatures. Yet, they persist in the dark. This ritual points to a sensory capability we are only beginning to map. The great white is not just a mouth, it is a giant swimming antenna tuned to the Earth's magnetic field. Inside the shark's snout are the ampullae of Lorenzini, jelly-filled pores that detect electromagnetic signatures. In the deep-sea abyss of the cafe, where there are no landmarks and no light, these sharks are likely reading the magnetic topography of the ocean floor. They are navigating by the very pulse of the planet. When they dive, they are likely tracking the deep scattering layer, a massive migration of mid-water organisms using a combination of magnetic navigation and an olfactory bulb so sensitive it can detect one drop of blood in a million drops of water. We spent 40 years watching them at the surface because that is where we are comfortable. We filmed them breaching at Seal Island with Chris Fallows, marveling at the tons of force they used to launch into the air. We stood on the rocky cliffs of the Farallon Islands with Peter Pyle and Scott Anderson, counting the minutes of a predatory strike, but those moments represent less than 10% of a great white's life. The data from the tags tells a different story. It tells the story of a deep-sea navigator that spends the vast majority of its time in a world we cannot see, performing rituals we cannot yet name. The surface shark is a mask. The real animal belongs to the abyss. The White Shark Cafe is not a feeding ground. There is not enough prey there to sustain a population of this size for months. Instead, the leading theory suggests it is a massive, mid-ocean leca mating ground hidden by 1,000 feet of saltwater. The rapid oscillating dives are the shark's version of a courtship display, a test of stamina and sensory prowess performed in total darkness. If this is true, it means the most famous predator on Earth completes its most vital life cycle in a place where humans cannot follow. We have tagged them, filmed them, and named them, yet they remain as elusive as the giant squid. Consider the energy required for Nicole to cross the Indian Ocean, or for a male shark to dive 150 times a day in the North Pacific. A great white's heart rate slows to a near standstill in the deep, but its muscles stay warm thanks to a specialized heat exchange system called the rete mirabile. This biological machinery allows them to function in the cold of the twilight zone, while their prey grows sluggish. They are the only creatures of their size capable of bridging the gap between the warm surface and the freezing deep. They are the masters of two worlds, using the deep scattering layer as a private highway that spans the entire globe. The records filed under the TOPP program and the Wildlife Conservation Society don't just show migration patterns, they show a species that has survived 5 mass extinctions by being smarter than its environment. When the 2005 tracking data showed Nicole returning to the exact same South African reef where she was tagged, it proved these animals possess a spatial memory that rivals any migratory bird or whale. They know where they are going, and they know exactly how to get back. The ocean is not a chaotic wilderness to them, it is a structured map of magnetic lanes and thermal corridors that they have walked for millions of years. What we once viewed as a simple, bloodthirsty killer is actually a sophisticated biological anomaly. The great white shark is a living sensor, a creature that perceives the world through electricity and magnetism, traversing thousands of miles of desert to meet in a secret location, for reasons we are still guessing at. Every time a tag pops to the surface and beams its data to a satellite, it reminds us that the map is not the territory. There are still places in the modern ocean where the rules of biology are rewritten every single day, far beneath the waves and away from the cameras. What the index concludes: the great white shark is not a coastal predator, but a deep ocean navigator that utilizes the Earth's magnetic field to conduct undocumented social rituals in the abyss. Subscribe a new breakdown like this every day.